Hi, this is Thomas from Apex Game Tools. In this first video on the load balancer, we will be looking at the basics. So the load balancer is a service in Apex Path, which is used by Apex Path itself, but also exposes its functionality to you, so you can use that as a user. Now, in this first video, we'll be looking at the basics, how it works, where it's located, how you can configure it. And then in the second video, we will be looking at how you can actually use it yourself to execute different types of actions. So let me start by explaining briefly what the load balancer does. It's basically an alternative to coroutines. It enables you to execute some sort of action at an interval. So if you don't want things to run every single update, you can use the load balancer to spread out the work across several frames and thereby have a more smooth frame rate. So let's start by having a look at where to find the load balancer, and then we'll look at how and what it is used for. So it is located on the game world by default. This is where we'll find it, and as you can see, we have it here. This is a very simple game world with just the load balancer on it. When you expand the component, you will see that it has actually a number of different load balancers on it. In this case, we have 6 defined load balancers and a special load balancer called the marshaller, which is one we will cover in the second video. Now, some of these are used by Apex products, other Apex components. These are the dynamic obstacles, the scanners, and the steering. So while you shouldn't directly use these yourself, you should be able to configure them, and you are able to configure them to match the needs of your game. And we'll get back to that in just a second. Just cover the rest of them. So the default load balancer is one that you can actually use to schedule your own actions. Again, this is covered in the second video. And then we have 2 example load balancers, this one here and the extra load balancer here, which is simply additional load balancers defined for this particular examples project. And again, this is a topic for the second video. Now, before I touch on when you want to reconfigure the existing load balancers, it might be an idea to watch an example of how it actually works and the purpose it has. Now, to do so, we have this simple scene where I have some pillars. Let me just start it so you can see. Basically, I have a number of pillars, 165 to be precise, that are simply moving up and down. Now, right now they're moving up and down in the update loop, so every update they will be moving a little bit up or a little bit down, but they do so every frame. Now what we would like to do is delay this so that they only actually move every 1/10 of a second. One way to do that would be to alter the logic of the update so that it actually checks at times to see if enough time has passed and blah blah blah. That isn't exactly optimal, so we have some other options instead. One option is to use a Unity coroutine. So let's have a look at how using a coroutine will change things. So as you can see, switching to a coroutine will now slow things down. It looks very similar to the update, it just goes slower. And this is basically how the coroutine works. It will still update all 165 pillars at the same time, that is the same frame. And it will just do so with, in this case, a 1/10 of a second delay. So now if you look at the profiler, what does this mean? Well, this means that I just stop it here somewhere, and then I'm just going to find a frame where it actually kicks in. As you can see here, we have the pillar toggle coroutine executing on this frame. It executes on all the 165 pillars at the same time, taking about 1/3 of a millisecond. Now, obviously this is pretty fast, but this is also a very simple thing it does. So one problem with using a coroutine is that it does all of them at the same time, or this may or may not be a problem. Obviously, if you do want them all to be updated at the same time, then this is what you want. If not, then it might be a problem because it can actually create some dips in the frame rate because you have everything happening in the same frame instead of having them spread across several frames. So this may or may not be a problem, but what is definitely a problem is that it actually allocates 2.7 kilobytes of garbage every time it runs, which is pretty lame, to be honest. So let's move on and have a look at how the load balancer does this instead. So now we have the load balancer instead. This is now scheduled on the default load balancer with its default settings. Now, as you can see, this looks a little bit different. Very shortly after having started it on the load balancer, as you can see, the various pillars actually go out of sync. So only some of them are updated and some are not. So they basically spread out across several frames. So now if we look at that in the load balancer, it looks a little bit different. As you can see, we have the load balancer update here, and it updates for 1/10 of a millisecond, but it also only updates actually 20 of the pillars, because this is the standard or default setting for the load balancer. We'll see that in just a second, but this is the default for how many objects it will process per frame. So if we move along several frames, as you can see, it actually does some work every frame. It will execute 20 of the 165 every frame, using about 1/10 of a millisecond every time. So this is an alternate. As you can see, it also operates quite differently, because you don't have all of them updated at the same time. So if this is a problem for you, obviously you will want to edit the default so that it doesn't only process 20. There's actually another reason to do that as well, and I think we'll get back to that after we look at how you can update this to actually execute on all 165 at the same time. So for that, we need to just stop the simulation for a second, and then we go to the default load balancer, and as you can see, it has some options that you can configure. So let's just quickly touch on these. So the first one is the update interval. That is what we decided on to be 1/10 of a second. So every 1/10 of a second it will update the pillars. So this means that all of the pillars will have 1/10 of a second between their updates. The next one, auto adjust, we'll just skip for a second, and then we'll go to updates per frame. So this is basically what we were seeing, that it only updated 20 per frame. If we were to change this to 165, which means everything, this should actually change how it updates. And finally, we have a max update time. This works in conjunction with the max updates per frame. So this also sets a limit on how many milliseconds that it is actually allowed to use per frame. This will have precedence over this one. So if it actually uses 4 milliseconds and only did 100, then it will still only do those 100. It won't actually continue to 165. So this is basically just to set up the budget for the load balancer. How much can it use per frame? Now, having made this little change, let's just go back, start the simulation, and we'll switch to the load balancer. And as you can see now, we actually have the pillars moving up and down, all of them at the same time. And if we switch into the load balancer, into the profiler, we will find the update. And as you can see in this frame, it didn't do anything. So let's just switch to a frame where it did. And there we go. We have the frame. Again, we are back at how the coroutine worked, so that we have all of the updates done in a single frame, and then it will have some frames where it doesn't do anything, and then it will again do all of them in a single frame. So it uses just over a half a millisecond to do the 165. So this is a little bit longer than what we saw the coroutine use, but we have absolutely zero allocation. And of course, we also have the flexibility that we can later decide that we actually do want to spread it out a bit across frames instead of having everything done in a single frame. Well, let's go back and look at the potential problem I mentioned before. So I'm just going to go back here and reconfigure this. Basically, just restore it to its defaults. So we have 20 updates per frame. I'm going to start it again, and we're going to go to the load balancer. Now, we saw this before, that it actually went out of sync quite quickly, and this can be okay. I mean, you may want this behavior, but typically you don't, because what we're seeing here is actually a violation of the contract that we have set up. What we want here is to have each of the pillars updated every 1/10 of a second. Now they can spread this out across several frames, that's fine, but each pillar must be updated every 1/10 of a second. Now this is actually not happening here. And the reason for that is that we simply have too few updates per frame to enable us to actually do all of the 165 items within a time span of 0.1 seconds. And the way you can see this, and this is typically the way that you will identify that you will have problems with the load balancer, is to add the component called the Load Balancer Performance Visualizer, which will show you how the load balancer is currently performing. So right now we only have stuff going on in the default load balancer. As you can see, we have the 165 items in it. We have 20 updates per frame. And then we have something down here called frame overdue average, and further down we have an average overdue average. What these overdue figures mean is that this is the amount of seconds that on average each pillar is delayed outside of what it should have been delayed. So as you can see, on average this is 19 milliseconds, so it has actually been delayed in addition to the 1/10 of a second that we intended for it to be delayed between each update. It is actually delayed a further 19 milliseconds on average. And this is basically what puts things out of sync, because things are delayed, so they're not actually getting updated every single cycle, so to speak. So like within 1/10 of a second we should have updated all 165 items, but most likely we will only get, let's say we update 120 items within that period of time. This leaves 45 items that will then need to be updated in the next start of the next cycle, and that will then leave out the remainder again from that cycle, and so forth. So basically it will always be behind, and this will get worse and worse and worse, and as you can see, this will bring them out of sync, severely out of sync, as you can see. Now, as I said, this is only a potential problem, because you may actually want this type of functionality, that you actually want things to be oscillating like this, up and down. Then you can do like this and it will work just fine. You just need to know that the interval is actually not being respected here. They're not executed precisely once every 1/10 of a second. Alright, so I hope you understood that part. So now let's see if we actually see this as a problem, which we usually will. Let's see how we can fix it. So to do that, the easiest way is to use this option that we just skipped before, called Auto Adjust. Now what that will do is it will adjust so that it will fit all of the updates, in this case all of the 165 updates, within the specified interval. And it will then adjust these values down here by itself so that it will actually fit. So let's do that and see that in action. So I'll just tick on Auto Adjust, go back, start the simulation, and then we will switch to the load balancer. And now, as you can see, what it has found is that if you actually allow 27 items per frame, you have no overdue time. So 27 items should be enough for this to actually run smoothly without having any oscillation. And as you can see, that is actually what it's doing. You can see they're not out of sync in the same way as they were before. They are slightly out of sync, and that is expected because we are actually spreading things out across a frame. But this time we're actually having 27 per frame instead of 20 as before. So we have none of them being delayed, so all of them will actually have their update every 1/10 of a second, which is what we wanted. So how can we use this? Well, obviously one way is to simply just have the auto adjust on, but a better way to avoid having the auto adjust calculations going on, you can also simply have the auto adjust on, look at the numbers, and then go back and adjust it. So now let's just have it at 28 to have a little bit of a buffer, and then we'll go back and start it, and you will see that now, as expected, it will behave as before. There are 0 overdue times. All right. I hope that makes sense. So how and why should you know this? Well, the thing is that some of these load balancers that I mentioned before are used by the different APEX components, dynamic obstacles, scanners, and steering. And depending on how many of these you actually have in your scene, you may actually need to adjust the default settings so that they will work as expected. So let's, for instance, say steering. This is used by the steering so that if you have many units, you will probably want to adjust the max updates per frame on this load balancer. So let's say you have hundreds of units, then having 20 per frame is probably not going to cut it. So how do you find out if you have to adjust it? Well, you just do, as I just said before, you simply add this component called the Load Balancer Performance Visualizer, and then you start your scene with everything set up, with all the dynamic obstacles, all your units and everything walking around, and then you look at this component, and you will see for each of these, as you can see now, we have the default load balancer up here. For the others, they're just listed underneath here. So if you had the steering one, you would scroll down here and you will find, so if you had anything listed here in the frame overdue average, or in particular in the average overdue average, which is like across all of the updates in total, if you this is non-zero, or well, it can be very small, that might be okay, but if it is not, if it is in the millisecond range, you probably want to change it up so that you get a different amount of updated items. So to fix it, you do exactly what we did before. You go back to that load balancer, you do an auto adjust, and then you see what it comes up with, and then you simply adjust the numbers accordingly. Now I really hope that made sense, and that's pretty much what we have for this video. In the next video, I'm going to cover the different options you have for using the load balancers for your own purposes. So see you in the next video.